Hello everyone and welcome to section 2.9 day 2, which is on the proof portion of this section. So we're going to start some two-column proofs using the theorems that we just learned in the last section. So I'm always going to start this off the same way by writing down my given. So angle 1 is congruent to angle 2. That is my given. Now, I need to prove that this line M is parallel to line L. So angle 1 is congruent to angle 2. Now what is the relationship between those two angles? Well, they are alternate exterior angles. Since those angles are congruent, I can say right away that line M is parallel to line L by the alternate exterior angle converse. And if you wanted to write it out, you could say, since the alternate exterior angles are congruent, then M is parallel to L. Here's my next proof. I am, again, just going to write down my given, which says angle 1 is supplementary to angle 3, so angle 1 and angle 3 are sup. And that's given. Now, given that angle 1 and angle 3 are supplementary, they don't really have any relation to each other here. So I need to get a relationship, either alternate exterior, alternate interior, I need something to prove that these lines are parallel to each other. So if I look at angle 1, I see that angle 2 here and angle 1, they're the same. So I'm going to write angle 1 is congruent to angle 3. Or not congruent to angle 3, angle 2, sorry. Is congruent to angle 2 because they are vertical angles. And vertical angles are congruent. So angle 1 is congruent to angle 2. Therefore, I can also say that angle 2 and angle 3 are supplementary. And that is by substitution. Therefore, if 2 and 3 are supplementary, like I just said they are, and 2 and 3, the relationship between those two is they are consecutive interior angles. So, by the consecutive interior angle converse theorem, I can say that line M is parallel to line N by that theorem. I've just proved that 2 and 3 are supplementary, and by definition, consecutive interior angles should be supplementary if lines are parallel, which is what the converse says. Okay, that's number 2. Let's move on to number 3. Number 3, again, I'm just going to write down my givens. Angle 1 is congruent to angle 3, and we're told that AC, line AC, is parallel to line BD. So those are givens. Given. Now I'm just going to kind of mark my picture a bit so I can see. Angle 1 and angle 3 are congruent, and angles, or line AC, this one, is parallel to line BD, this one. Okay, so if you ever get confused while looking at a picture, because we're trying to prove that AB and CD are parallel, if you ever get confused while looking at a picture, just go ahead and extend your lines a bit. Extend them down, extend them up, so that you can see them a bit better. Okay, I kind of did it off camera and I extended my lines. I darkened the parallel arrows so that I can see that better. Now, I'm told that these two lines are parallel, and now if I look at this transversal here, I know that angle 3 and angle 2 are congruent because they are corresponding angles. So angle 2 is congruent to angle 3 by the corresponding angle theorem. I'm just going to write corresponding angles. Now, if 1 is congruent to 3 and angle 2 is also congruent to angle 3, then angle 1 is congruent to angle 2 by the transitive property. Now, if you look at angle 1 and angle 2, and what we're trying to prove that these lines are parallel to each other, Angle 1 and angle 2 are alternate interior angles on those two lines that we're trying to prove a parallel. Therefore, we just proved that angle 1 is congruent to angle 2, so we just proved that alternate interior angles are congruent on those two lines. Therefore, we can say AB is parallel to CD by the alternate interior angle converse. Oops, don't use the converse. Since angle 1 and angle 2 are congruent, and they are alternate interior angles, we know that AB and CD are parallel. And that's it for this section. This section was pretty short, so go ahead and take a look at your homework, and we'll see you all tomorrow.